All right, here we go. So in the pink, okay, don't do your work in the pink. There's not even close to enough space. So do not do any work in the pink. So don't do any work in the pink. All your work should be done in your notebook or on other paper. Okay, no one talk. Focus. Okay, look up. Look up. Okay, so again, as always, you have to follow how I'm thinking. You can't follow what I'm doing. Like, how I think is most important, then the doing will follow pretty easily. So I look at, it's an AP test. I look at the problem. They're asking me to find the value of an integral. If I could use a calculator, if it were the calculator section of the test, super easy. In fact, they won't ever ask it. It's too easy. I would just pick up my calculator, type it in, I'm done. Okay. This, however, is a case where we're practicing for the 80% of the AP test for which the calculator is not allowed. So again, don't do any of the pink homework at home. Just we'll do it together in class to get started because it involves quite a bit of things. This looks like a pretty simple problem. I mean, there's no words. There's just, find that integral. But it does involve a few concepts you've got to put together. So because I cannot use my calculator, I have to find another way. I've told you repeatedly, the fundamental theorem of calculus is the most tested idea on the entire AP test. Here's another example of that. I don't have any way to find the value of an integral. The fundamental theorem says if you can't find the value of an integral, don't. Do this instead. Like if you can't do the orange because you don't have a calculator, do the green. Because the green says all I need is the formula for whatever is called f, and then I can plug into that formula f a value and then another value and just subtract. So that's our strategy. But to get there, we have to keep track of like what is f prime. So first thing I want you to write on your paper, not your pink packet, is you have this problem, so write that down. So write the integral from 0 to 8. Instead of root x, we're going to do it like this. 1 all over x plus 1 to the 1/2 power dx. So write that on your paper. Next step is to take advantage of a rule from algebra that says 1 over something to an exponent is exactly the same as that same something raised to -1 multiplied by the exponent. That allows me to rewrite this. So put an equal sign, integral 0 to 8, parenthesis, x plus 1, all raised to the -1/2 multiplied by dx. Questions about anything? Please look at it.
Why are you doing that?
Outstanding. No, really. No, I really want everyone always asking, like, why? Here's where I'm at. I look at this, I'm just having a little bit of a hard time visualizing what they have given me. So I thought it might be easier to see if I separate a little bit. So I separated the dx from the rest of the formula just to make it in a form I'm more used to seeing. Get there? The very next step is purely experience. Like I've just learned that a root in the denominator is sometimes okay, more often better to move everything to the numerator. So just from experience, I've learned that that usually is better. Otherwise, there really is no other reason so far. So other than that, nothing else I've done has any reason. I'm just trying to get it into a form that's a little easier to see. Okay? I'm going to pay Olivia a ticket for that one. I do want you asking why. I mean, it seems like a silly question, but you got to keep asking, like, why am I doing it? It's just to see it better. So now, this looks more like the fundamental theorem to me, because I'm looking at this portion of the fundamental theorem. I've got an integral. I'll have Kate help me for a second. So Kate Nelson, I've got an integral. What's the A?
0.
And the B is?
A.
Good. So I'm going to think of this, 2 points for Kate, this as f prime. So it at least matches what I have written here. I'm just going to think of that as f prime. Now, please do not memorize that it's f prime. I'm just considering it to be f prime temporarily. Nothing in the problem says that it is for sure f prime. But it will help me talk about what I'm doing if I think of this as being f prime. Questions? Cool. So we'll go to Maddox now. The fundamental theorem up here says that if I'm trying to integrate some formula that I happen to call f prime, right here, the fundamental theorem says if you don't have a calculator, stop trying to integrate. It's not really possible because you can't multiply a million times by hand. So we're going to do this instead. We need to go find f. So as best you remember, Maddox, how is the formula called f related to the formula called f prime?
I don't know.
So I'll help. So if we remember Danica's chart would look like this. Put this off to the side a little bit. So Danica's chart would say we've got f, we've got f prime, we've got f double prime, and I'm going to introduce a new idea. Sometimes we refer to something called capital F. 2 points for Maddox. We'll go to Ian. So Ian, how is f prime related to f?
It's the derivative of f, right?
Yeah, f prime is just the derivative of f. So if I say that backwards, I would say that f is the antiderivative of f prime. F is the antiderivative of f prime. So 2 for Ian, back to Maddox. So if I'm thinking this as being f prime, then here's my f prime, integral of f prime. This f is going to be the antiderivative of this. But I could also think of this as being f. And according to what I wrote up here, Maddox, what would be the antiderivative of small f?
Capital F.
Capital F. So you can think of the fundamental theorem multiple ways. Here's one version of the fundamental theorem. Here's another. You could write the integral from a to b of small f is also the same thing as capital F with a b plugged in. Subtract capital F with an a plugged in. That's why I said this is not technically f prime. This could be f. It depends on how you want to think about it. Question. 2 more from Maddox. Okay, cool. We're going to think of it as f prime for a minute. So now what we want to do is come over here. Okay, so on your paper, draw a line, because we're kind of stopping that thought for a minute. We have to change our thought. We need to go find, we're thinking of this as being f prime right here. We need to go find f. But in words, we'll go to Connor, how is f related to f prime?
It is the anti-differential of f prime.
Perfect. 2 points. F is the antiderivative of f prime. Here's how you're going to write that under this line. On your paper, write f is the antiderivative of f prime. It's the same integral symbol, but there are no numbers. So it's an antiderivative, not an integral. Questions? Cool. So next line, we could also write this. We could say, oh, therefore capital F. We'll go to Jessica Neeleman. So capital F would equal, like following the same pattern, Jessica, what would I write here?
The antiderivative of F.
Nicely done. Two more. Questions? Cool. All right, so that's the idea. So continuing our logic here, we need to find, we're going to think of this as being f prime. So, therefore, our version of f is going to equal the antiderivative of our thing we're thinking of as being f prime. X plus 1 to the negative 1/2. Questions? Okay, reminder of the big picture here. The goal of the problem is to find the value of this integral. But we've temporarily left that alone, and we're doing a different problem. We're saying, okay, we're going to consider what's inside the integral. That's called the integrand. We're going to consider the integrand to be f prime, and we're going to go find the antiderivative of f prime. We're going to call that f. So we're doing a little problem within the problem. Cool? All right, here we go. To find antiderivatives, your first choice is to use a formula if you can. Hence the cardstock. So I would have done what Hunter did. I would have mounted it properly in my sheet protector because I'll need this forevermore. Okay, the sheet shows 10 rules. Really, there's only 5. So everybody look at the sheet as I talk. Like everybody look at the sheet as I'm talking. Notice on the left-hand side, there are 5 separate rules. The left-hand side, there's a rule for x to the n, e to the x, natural log of x. Notice 1 over x, right? Yeah, 1 over x. Sine x, cosine x. 5 simple rules. On the right-hand side, all you see are the exact same rules, except that instead of x, it says ax plus b. You see what I'm talking about? So don't think of them as 10 rules. There's 5 rules and an expanded version for each rule. It's easier to memorize if you're only memorizing 5 things plus an expanded version. With me? Okay. I look here, and I look at my blue sheet, and I notice right away, this is ax plus b raised to a power. That's a rule. It's the expanded power rule. So I can find that antiderivative by doing nothing more than just copying the rule. So we'll go to Stella. So if I'm saying that this rule fits, what's the A, Stella?
1.
What's the B?
1.
What's the N? Perfect. So I'm saying that capital F, sorry, small f is the antiderivative of this f prime. So my small f, according to this rule, this antiderivative right here can be rewritten like this. So what would I write? We'll go to Tessa now, too, for Stella. What would I write, Tessa?
The yellow box?
Right, because what I'm doing is I'm noticing that this yellow box can be made to look exactly like this yellow box by choosing A and B and N just like Stella did. So the rule says I don't have to write this yellow box. I can instead write this yellow box. So I'm going to replace this yellow box with this yellow box using the A, B, and N that Stella chose. So what would I write, Tessa? And A is what number in this
Oh,
case?
sorry.
You're good.
1.
So I have 1 over 1.
And then 1x, or just x, plus 1. And then negative 1/2 plus 1. Over negative 1/2 plus 1. And then plus c.
2 points. And C is just some number we don't happen to know the value of. So C is like 12, negative 5, I don't know, something. Questions? Perfect. Please.
On like a written portion for this, would we have to clarify that it's like f of x, like if that's the one we've chosen, or because we don't know, would we just leave it blank? Just
Oh, that's
trying to
outs-
find the antiderivative.
That is outstanding. Stay with me, I'll pay you a full ticket here in a second. So Hunter, in my little example, to make talking a bit easier, I decided to refer to this formula with what name? Like I decided to call this what?
F prime.
Good. And so once I call that f prime, the antiderivative of that formula right here has to be f. You comfortable with that?
Yeah.
Good. But I could have called this f, meaning the antiderivative of this formula would have required what name, Hunter?
Large f.
The large f.
The left.
Okay? That's actually not a rule, but it is something they use on the AP test a lot, so I'll use it. Good there? So it really doesn't matter which one I choose, I just need to choose something. Eventually, once I feel like you're comfortable with this idea, we'll write quite a bit less, and we won't have to use f or f prime at all. So right now, they're just kind of temporary. Eventually, I won't be writing either one. So I won't be writing f, I won't be writing capital F, I won't be writing f prime.
It'll just solve the problem.
There'll be a way to solve without that notation. It's a good call. Please.
Why wouldn't C just be 0? Like, why can't we just assume it's 0 if it's not?
Oh, C could be 0, but we just don't know. It actually could be something else. So we can't assume that it's 0 because we have no information that would validate that. We just for now have to assume that it could be 0 or something else. I don't know if that made any sense. Good enough for now? 2 more for Lily. Other questions here? Oh, please.
Wait, so are you ever going to put a number in for C, or is it always going to be the equation as like a number you don't know?
Let's write F slightly differently, then I'll answer that question. It's very good. 2 more. Claire, help me out. What's this the same as, Claire?
N plus 1.
It is. And what number is that in this case?
1/2.
There we go. So something to the 1/2 power is just square root. What's the number on the bottom, Claire? Also. Dividing by 1/2, Claire, is the same as multiplying by what? So I'm going to write F, 3 points for Claire. That was a good job. This is really just x plus 1 square root multiplied by 2. Plus the constant. Questions? Please, John. Right, so anything to the 1/2 power is square root. Same thing, 2 points. So Sam, just summarizing again, I chose to call this formula what, Sam? So I actually chose to call that f prime because it was the formula inside of the integral. You with me?
Yeah.
Therefore, the antiderivative of f prime must be referred to as small f. Good with that? So then over here I did it. I said the antiderivative of my f prime, that's got to be small f. So I've got my formula now for small f. 2 points for Sam. Jason.
Yeah.
If I had called this small f, because I get to choose, I can call it whatever I want, what would this have had to have been called?
Capital F.
2 points. Everybody good? Please.
Okay, wait, this is
No,
kind
keep
of dumb,
going.
but why is a half, like anything raised to be a half square root?
Square root.
Yeah.
That's not dumb at all. I'll pay a full ticket for that one. The explanation is lengthy, and I don't honestly have it off the top of my head. Yeah, it's something I learned before calculus. I haven't really gone back to where it came from for quite a while, so I honestly can't tell you. Yeah.
Just something you
For
don't
now, just
memorize.
memorize.
Okay.
Yeah. Yeah, I don't have a good reason.
Okay.
Yeah, I've got it memorized. I use it. Can't remember exactly why. Dead honest on that one. Good question. Anybody else? Okay, next thing. Kate, your question was, say it again.
Are you ever gonna put a number in for C or is it just?
Gotcha. Here's the answer. Look up, everybody look. On the AP test, if they ask you to find just an antiderivative, all of the answers will end with plus C. All choices. So it's no big deal. They all say plus C anyway. If they ask you to find a formula for F and they give you some other information, like they tell you the value of F when X is 3 is 8, that information will allow you to find the actual number C. And it could be 0, but it could also be something else. But knowing this will allow you to find C, because what you can do is in place of X, you can put a 3. So, Anna, what's 3 plus 1?
4.
Square root of 4 is 2 times 2 is. So we would know that 4 plus C would have to equal 8. So what would C have to be? 4. That's how you can find C. 2 points for Anna. Please.
And then will that, then you could find, like, keep that C as like 4 for a different X, let's say?
Oh, yes. Yeah, that would be, even though, no, it's very good, Ian. 2 points. Even though, and 2 for Anna if I forgot to say it. Even though, Ian, you found the value of C using a specific X, because it worked for the formula F, it will work for all X.
Okay.
Yep, it's perfect. That answered a little bit, Kate. When we're doing an integral, like we're going to use F because we're going to go take F and plug in our A and our B. When we're using an antiderivative to find an integral, the C actually is irrelevant. It's going to subtract out anyway, like it'll disappear. So those are 3 examples. 1, sometimes the answer does say just plus C. Sometimes you'll use information to go find the value of C. Sometimes it won't matter. And there's no other case. Good work. 2 more. Anybody else? Awesome. Okay, let's go to Gideon. We started out by referring to this as F prime. We said we can find the antiderivative of F prime right here. We found the antiderivative of F prime, we call that F. Gideon, can you think of any way we could check our work at this point to verify that we are on the right track, that we're doing the right thing, we haven't made an error?
You could double check your work.
So you know specifically what we could do to double check. Like we can do something completely different from what we've done, and it will verify that this formula here for F is the correct formula for F.
Oh, you could take the derivative.
There we go. 2 points for Gideon. I can take the derivative of what I have. So Lexi will help me. So Lexi, here's F. What would I write as F prime according to this F? Like I know F prime is supposed to become this or this because I just called that F prime. But I want to take this F and find F prime. How do I do that?
Would you have to go back to Unit 2 stuff?
Nicely done. Okay. So what do I write, Lexi?
You'd have to do, so you'd start with just the square root rule, or would you have to do something with the 2 first?
No, you're doing just
Multiply
fine.
Constant?
Yeah, the 2's a multiplying constant, so we can just write that down.
And then you do 1 over,
There we go.
it'd be 1 over 2 to the g of x.
You're doing great. It's been a while. Don't forget the chain rule portion.
dx.
And then Lexi, what would be the derivative of the C?
0.
0. points for Lexi. Questions? You good? So Paige, right here, factors or terms, Paige.
Factors.
Good. So factors can divide. So those divide to make 1. What would this equal, Paige?
Just 1.
Just 1. And Paige, what's this going to equal?
Would you move that over to your side?
No, because C is a number like 5. And what's the derivative of any
so
constant? 0. So that's 0. So we just found that f prime is equal to 2 for Paige. F prime is the same thing as 1 over the square root of x plus 1, which is exactly where we began, right here.
Did you not need the exponent then?
Say again.
The exponent make it 1/2, the negative 1/2 square root, you do not need it.
This one here. Are you comfortable that this right here, Jason, is exactly the same as this?
Yeah.
They're the same thing, so I can think of it either way. Root means 1/2 power. So what I just circled is an exact copy of this.
Oh.
Do you see it? 2 more. Anybody else? Awesome. So far so good. Like everything's working. I thought of this as being f prime. I went and found my antiderivative. I've got an antiderivative formula now. It's right there. Well, no, sorry, that's the f prime. Here's my antiderivative formula right here. F. Please.
Do you have to like check your work and do the derivative?
You don't. I think it's good to do it once to just, hopefully your brain, it's kind of how our brains work. If they can see where things come from, the memory is better. Please, 2 more.
I think you already explained this, but why did we do a derivative again? Like, how is it going to work?
So are you okay that I just kind of randomly chose to refer to this formula as being f prime? Good. So are you okay then that because of what f prime represents, f must be the antiderivative of that f prime? So are you comfortable with this statement right here? F is the antiderivative of f prime. So then all I did was I plugged in my formula for f prime right here. I used my rule sheet to say, oh, that means that the formula for f is this formula.
Oh, and then you just...
And then I said, let's just check it. So we take a derivative. Hey, we just completed the circle. Yeah, it's actually 2 more for Lily. It's actually the first time this year that you've done the complete circle. We started with a thing we called f prime. We went this way to create a new formula called f using an antiderivative rule. We then took the derivative of f, and we got right back where we started, f prime. Questions? Sweet. All right. So the next thing that we must do now, we have our formula for f. The fundamental theorem says, instead of doing the integral of f prime, like up here, look again, instead of doing the integral of f prime, don't, because you can't, you don't have a calculator. Instead, use the formula for f. So we're going to do the blue box. Questions? Okay, so moving down again, kind of a start over. Write the following on your paper. This is what Hunter asked about. He said, how do we do this with kind of all this, got all this writing, how do we do it with less writing? Write the problem 0 to 8. We'll do the simplified version, x plus 1 to the negative 1/2 dx. Write that down. Okay, directly below that, write equal. This is what I said to Hunter. I'm not going to really write f or f prime anymore. I'm going to think of that as being f prime. I'm going to use my rule sheet to find f. I already did that, so I can write on the next line f. F happens to be 2 multiplied by the square root of x plus 1. That's f. Here's f prime. Here's f.
Do I have to add C?
Oh, thank you. 2 for Dylan. Put that in parentheses. According to the fundamental theorem, Dylan, what are we supposed to do with this formula we're calling f?
Subtract 2 points.
Supposed to plug in 2 numbers and subtract. Here's a new symbol, 2 more for Dylan. That symbol represents doing what I just said. Except I don't want A and B, I want 0 and 8. That was a mistake. Come on. So write that down. That's a new symbol, we haven't used that before. Question? Cool, so go to Riley. So the fundamental theorem says, instead of doing this integral, we're going to go find the antiderivative of that formula. Here it is. So here's the original formula, here's the antiderivative. We're going to plug into that an 8 and a 0. So Riley, if I'm plugging an 8 into this antiderivative formula, what would I write?
2 square root 8 plus 1.
Pause for a minute. Oops, wrong way. And I have my plus C. Now when you have a subtract with multiple terms, make sure you put a parenthesis to avoid a mistake that's common. So then Riley, what would come next?
And then 2 square root 0 plus 1 plus C.
2 more for Riley. Questions? Please.
Okay, wait, why do you put this C on? Because I did that it's like on the end of that equation, but right above, like your formula right above, right under that box, it says
Let me number the
DX.
middle help. Hold on. So we've got this item, this item.
Yeah, 2.
So item 2, keep going, Jessica.
Well, I guess it's like the transition from 2 to 3, but there's like dx on the end of 2, but then on 3, you take off dx and you write.
No, it's very good. Several things happened. I'm going to pay a ticket for this one. Here's multiple things happened. We started with an integral. Good there?
Yes.
The formula inside the integral we temporarily named to make talking easier. It's not its real name, it's just something we call it. What are we calling this formula, Jessica? Good. The fundamental theorem says if we're integrating f prime, we can accomplish that a completely different way. We can go find a brand new formula called f. Good there?
Yeah.
How is f prime related to f?
F prime is the derivative of f.
Very good. That means f is the antiderivative of f prime. So on our other work, further up, we found the formula for f.
Oh, okay.
We went and found the antiderivative of f prime, and that produced the formula for f right here. You with me?
Yeah.
It's really good. So then back here, we take that brand new formula. So that's why this changed completely.
Right.
The integral symbol's gone, the dx is gone, because the equal sign says you don't have to do this. You just need to know what f is. You know what f is. Now we need to plug into that f these 2 numbers. That's how we got from 2 to 3.
Okay,
It's
yeah.
very good. Most important concept on the entire AP test right there. What you asked about. That's why it's worth so much. Other questions? It's really good today. Please.
So that new like symbol with the 8 and the 0 that you like said new. So is that kind of like when it's had like the line and then x equals like when you're trying to solve for a certain x? So if it just has like 8 and 0, and you just like you plug in both of those options.
Yeah, it's very similar. It's just slightly different. With a bar, and then they'll write x equals 0, indicates to simply just plug in the 0.
Okay.
With two numbers, it says plug in both and subtract. Yeah, that's very good. That's where it comes from. Two more. Anybody else? Please.
Should there be parentheses around the first 2 square root of 8 plus 4 plus c?
So like this one, Brooklyn.
Yeah.
2 points. Because there's no leading subtract, it's not required. It doesn't hurt anything. In fact, some people find it helpful to kind of think of it as parenthesis minus parenthesis. We will drop them eventually, but it doesn't hurt anything. Good call. 2 more. Okay, so Charity, what would I write on the next line? So what's this? What's 8 plus 1? Square root times 2. So that's a 6. There's, like I said to Brooklyn, there's no, it's a plus out here, so when I distribute the plus, I'm okay. Just 6. Distribute the plus to the c, it'll become plus c. So Charity will stay with me for a minute. 0 plus 1, square root. Yeah, what is the square root of 1? So what times what is 1? 1, yeah. So square root of 1 is just 1. 2 times 1 is plus c. Now I distribute, so this becomes minus 2 and minus c. And like I said to Kate, notice the plus c and the minus c will add to make 0. That will always happen if you are using an antiderivative to find an integral. So I typically will stop writing the c in that instance. 2 more for Charity. Anybody else? So now this is all equal to 4. Everybody grab your calculator. It really will help your brain. Like I promise, you will remember it better if you do this, if you pick up your calculator and do this. Plug this in your calculator. This one's probably the easiest right here. Plug that in. Like literally go through the steps, it'll help your memory. Right here, number 2. Plug that into your calculator.
Wait, how do we erase it?
Yeah, how do you raise it?
Oh, so type, so you go math 9.
Yeah.
You're good. Parenthesis, x plus 1, close parenthesis. Then there's a caret.
Caret.
It's up arrow.
Once you go over it, just jump
Right here.
in.
Yeah.
Do like 2 parentheses.
Oh, the little,
Yeah, you got it? It's called a caret. I don't know why.
Or which one is it?
Right here.
Oh.
And then the exponent is negative 0.5.
I got 4, you're like. Yeah, I got 2.
4E. 4D. Oh, 4 0? Oh. That's because your exponent. Questions? Everybody should get up. Who got 4? Hands up. Who got 4? 4 points. Write them down. Funny. Pretty good? Okay. So yeah, it works, of course. I mean, wasn't expecting anything different, but it really will help your memory to see that they're the same.
I thought we're not gonna have a calculator.
You won't.
So then,
So that part won't be available to you.
how do you get the actual answer then if you don't have a calculator?
So we got the right answer. I didn't use a calculator at all.
Wait, did I say this? I don't know what.
Okay.
Wait.
You're okay. No. Hey. No. Back up. Like do the. No, I'm serious. Like it's a great. No, it's really. Look.
Oh, okay, I did not know. I
You're
got
good.
it. No, I don't get it. Actually, wait.
No. It's good to summarize. It's a good question.
Wait, is it because C minus C is 0? Okay.
Yeah.
Good job. Dude, I was.
Don't even worry. Anybody else? 2 for Olivia. Are we good? Comfortable? Awesome. Good luck. Hey, look. That's the idea, but it does involve several different things you've got to keep track of simultaneously. Just summarizing again, all we did was this. Carrie Ann will help me. We had an integral to start with. Inside the integral, there was some formula. The name is irrelevant, but it is some formula. The fundamental theorem says if you're trying to integrate some formula and you don't have a calculator, don't do that. Instead, go find a different formula. But Carrie Ann, how is this formula right here? We don't care about the names. How is this formula related to this formula?
It's the antiderivative.
It's the antiderivative. That's the whole key. You've got to find the antiderivative. Once we have that new formula right here, the antiderivative formula, we plug into that formula the two numbers, and then we subtract. And that's how we solve the integral. Questions? Okay, next one. Cool. Stop that video.